What are branch alkanes? Yeah, what are branch chain alkanes? Basically, they are hydrocarbons. But instead of they having only carbon atoms linked in continuous links or chains, they have one or more other carbon branches sticking out from the main chain. So if you look at the diagram we have on the screen, we have the main chain, then there is one sticking out from it. Let's see. So this is the main chain, then that is the branching. So this makes this compound a branching alkane. Good. Yeah. So now let's look at how to name them. So you can see that for this one, the main chain has 5 carbon in there, and then the branching is attached to the second carbon. Yeah, I think you can see that the branching is attached to the second carbon. So if you want to represent this using what we have on the screen is the displayed formula. There is another way of representing this same molecule using the condensed formula. What is the way of representing condensed formula? Because most of the time when you are asked to name an organic compound, they might not show you using the displayed formula. They will give you the condensed formula. So let's look at it. The first carbon, carbon number 1. How many hydrogens is it bonded to? 1, 2, 3. Did you see that? Yeah. What about the second carbon? It's bonded with 1 hydrogen at the top. Then CH3 added down. Did you see that? Yes. The second carbon is bonded with a hydrogen at the top and a CH3 added down. Then it is bonded with the next hydrogen, right? So now, the next carbon. So carbon number 3. Carbon number 3 is bonded with 2 hydrogens. I hope you see that. Carbon number 4. Carbon number 4 is also bonded with 2 hydrogens. And carbon number 5 is bonded with 3 hydrogens. So basically, it's either you see the displayed formula or the condensed formula. If you had not watched our lesson on alkanes, naming of straight chains, alkanes, in that lesson we actually explained how these organic compounds are represented. Yeah. So now let's go right into naming this organic compound. So what are the steps for naming this organic compound? Well, the first thing we have to do is to identify the longest continuous chain in this organic compound. The longest continuous chain. When we say longest continuous chain means a chain of carbon atoms that move on without interruption. So in a particular organic compound, there may be several long chains. So for this one, we have the first long chain. Let's count the number there. The one that has a rectangle around it. If you count the number of carbon atoms present, there are 5 out of the 1, 2, 3, 4, 5. Good. And that happens to be one of our chains. The other chain moves this way and comes down. If you count the number of carbons, you still have 1, 2, 3, 4, 5. It's still 5 carbon atoms. And the third one I've not shown, that is from the left. You have 1, 2, 3 carbons. So you should develop the skill of counting the number of carbon atoms in the longest continuous chain. So obviously, I'll still go for the first selection that I did. So this becomes the main chain. And there are 5 carbons in there. So the name of the longest continuous chain is pentane. You must have watched our first lesson on how to name straight chain alkanes to understand this. So any organic compound that has 5 carbon in it, yes, 5 in its longest continuous chain, the base name will be pentane. So this is it. So you have pentane. Now we have what we call the side chain. The side chain of this organic compound is known as methyl. Methyl is an alkyl group. If you struggle with knowing what an alkyl group is, we've actually recorded a lesson on that. So you must have watched that lesson before watching this. If you have not watched that lesson yet, then kindly watch it before you continue with it. So this is a methyl group. After identifying the longest continuous chain and naming it, we have to look for the side chain and also name it. But it doesn't end there. The next thing you have to do is to find the number or the position of the branch on the longest continuous chain. What does that mean? What it basically means is we have to first of all number the longest continuous chain. We number from left to right and from right to left. Left to right and right to left. There's a reason for doing that. The reason is simple. We want to check the position of the branch, but I want to check which of the numbering gives the lowest position possible. If you look at the top number, which is the red, the side chain, which is the methyl group, is found on carbon number 2, the red one. But if you consider the lower numbering, the branch chain is found on carbon number 4, the purple numbering, carbon number 4. 2 is smaller than 4, so we'll disregard the purple numbering and focus on the red one. So that means the methyl group is found on carbon number 2. So the name will be 2-methyl, meaning the methyl group is found on carbon number 2. The next step to take after doing all of this is to just combine the names. So now we have 2-methylpentane. So that's the name of this compound. Keep that in mind. Another thing to keep in mind, the fact that numbers are separated from names using hyphen. So 2-methylpentane. This is easy, but there's a much more complex example here. Good. So how do we name this organic compound? First of all, we have to identify the longest continuous chain, and there are a lot of longest continuous chain here. This is the first and obvious one. If we check the number of carbons, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons in this longest continuous chain, or in this chain. Good. There is another chain also, which is this. Start from the top, 1, 2, 3, 4, 5, 6. But for this one has only 6 atoms, so it cannot be the longest continuous chain. The first one gave us 8. This another chain, 1, 2, 3, 4, 5, 6. This is also 6, so it can be considered. This also another possibility, 1, 2, 3, 4, 5, 6, 7, 8. So you see, so you just have to check the chains and see which one gives you the longest continuous one of carbon atom. But we've gotten 2 of them that are 8, so I'll just revert back to the previous one that we got. So now we've confirmed our longest continuous chain. Any other thing that is not part of the longest continuous chain is known as the side chain or branch. Good. So now we have to name the longest continuous chain. What is the name of an alkene with 8 carbon? The name is octane, like octagon. So octane, we got that. So the name is octane. So we've successfully named the longest continuous chain. Anything attached to the longest continuous chain is known as what? An alkyl group, or is a branch chain. So you have to name these alkyl groups. The first one is methyl. This one is also methyl, and this is ethyl. If you have not watched our lesson on alkyl groups, kindly watch that to find this lesson quite easy. After we've identified the names of the alkyl groups, the next thing we have to do is to tell the position of each of the alkyl groups on the longest continuous chain. In order to do that, we have to number the carbons in the longest continuous chain. So we have, starting from left to right, we have up to 8 in red, and from right to left, we have up to 8, 1 to 8 in purple. Now let's check by considering the red. The first one, the methyl, the first one is found on carbon number 3, the top methyl, carbon number 3. The lower methyl is found on carbon number 4, and the ethyl on carbon number 6. Did you see that? That's for the red numbering. Disregard the purple. The red, we have 3, 4, 6. Now let's look at the purple, which is the lower one. The ethyl is found on carbon number 3. Ethyl is found on carbon number 3. Then the first methyl, which is the lower one, is found on carbon number 5. And the next ethyl is found on carbon number 6. That gives us 3, 5, 6. Now, which of the numberings do we take? Obviously, we are going to take the red one. This is why. When you add 3 plus 4 plus 6, that gives you 13. But if you add 3 plus 5 plus 6, that gives you 14. And since 13 is smaller than 14, we disregard the purple and focus on the one that gave us the smallest sum of the locations or the locants. So basically that's it. So now what does that mean? The first methyl is found on carbon number 3, so 3-methyl. The second methyl is found on carbon number 4, that makes it 4-methyl. And the third alkyl group is found on carbon number 6, 6-ethyl. So basically we have done with our work. The next thing we just have to do is to combine these individual names into one long name for this organic compound. But another rule to keep in mind is this. When it comes to arranging the alkyl groups, you arrange alphabetically. And in the alphabets, E comes before M. A, B, C, D, E. E comes before M. So we write ethyl before methyl. That's one rule to keep in mind. And the next rule to keep in mind is this. If a particular alkyl group repeats itself or appears more than one, you will use di if they appear twice, tri if they appear 3 times, tetra if they appear 4. So for this, methyl appears 2, so it will be dimethyl. So let's name it. So the name of this compound is 6-ethyl 3,4-dimethyl octane. It is called 3,4-dimethyl. Here's the reason. The first methyl is found on carbon number 3, the second methyl is found on carbon number 4, and then there are 2 of them, so dimethyl. So 3,4-dimethyl octane. I hope you get that. Another thing to pay attention to is numbers are separated from numbers using commas. So you can see the 3, 4, the 3 and 4, they are separated with a comma. These are important details to pay attention to. 6-ethyl. Names are separated from numbers using hyphen. Then ethyl -3, 4. Numbers are separated from numbers using hyphen. So 6-ethyl 3,4-dimethyl octane. So this is the name of this organic compound. Wow, very interesting. See you in our next lesson.